Imagine a time long, long ago, before cities, before forests, before even the sky was blue. Over 4.5 billion years in the past, there was no Earth, only a vast, swirling cloud of gas and dust, left over from the birth of our star, the Sun. This cosmic nursery held all the ingredients for our future home. Gravity, the silent, invisible force, began its patient work. It pulled tiny bits of dust and gas together like a cosmic snowball rolling downhill, getting bigger with every turn. They collided and stuck together, forming planetesimals, baby planets in a chaotic solar system. The young solar system was a violent place, a cosmic demolition derby. One of those bodies became proto-Earth. It attracted more and more material. Its gravity grew stronger. A relentless accumulation, building our world piece by piece from stardust. Our young Earth grew hotter and hotter. Constant impacts generated intense heat, and radioactive decay deep inside added more. The planet became a molten ball of glowing rock. Heavy elements like iron and nickel sank toward the center. They formed a dense metallic core, while lighter rocky silicates floated up and cooled into a thin crust. This differentiation gave Earth its layered structure. Then, an epic event, a Mars-sized object, Theia, collided with young Earth. Cataclysm. Earth tilted on its axis, seasons began, and molten rock blasted into orbit to form a debris ring. That rubble coalesced under gravity. It formed our moon, stabilizing Earth and shaping its destiny. After the fiery birth and the moon-forming impact, Earth began to cool. The surface, a sea of molten lava, slowly solidified into dark volcanic rock. Volcanoes erupted constantly, spewing gases into the sky, creating the first primitive atmosphere. It was not the air we breathe today. Nitrogen, carbon dioxide, methane, water vapor, no free oxygen. This blanket trapped heat and held the key ingredient, water vapor. Over millions of years, temperatures dropped, vapor condensed. It began to rain, a deluge lasting centuries or millennia. Rains filled vast low basins, forming the first oceans, a world-spanning storm turning rock into water. Water arrived from volcanoes and icy comets, the cradle of life. With oceans formed, the dance of the continents began. The crust broke into plates floating on a semi-molten mantle. Heat from the core drove them to move. They crashed into each other, they pulled apart, they slid past one another. This is plate tectonics. Over hundreds of millions of years, movement pushed land up from the waves. The first microcontinents. In warm, shallow, sunlit waters, the greatest miracle occurred. Life began. We do not know exactly how. Maybe near deep-sea volcanic vents or in a tidal pool struck by lightning. Chemical compounds organized into the first living cells. Tiny, single-celled ancestors of all life. From non-life came life. The epic of evolution had begun on our blue planet. For over 1 billion years, life remained simple. The oceans teemed with microscopic single-celled organisms, but one was about to change the world forever. Cyanobacteria, blue-green algae. They learned to harness sunlight through photosynthesis, taking in sunlight, water, carbon dioxide, and releasing a waste gas. A gas toxic to most life then, oxygen. At first it did not build up in the air. It reacted with dissolved iron, rusted and settled to the sea floor, forming vast banded iron formations we mine today. For millions of years the oceans acted as a giant sink. The planet was essentially rusting. Only after the iron was saturated could oxygen escape into the atmosphere. Around 2.4 billion years ago, the Great Oxygenation Event. For anaerobic life it was catastrophe. Oxygen was poison, triggering one of Earth's first great mass extinctions. Sunlight acted on oxygen to form ozone, creating a protective shield that blocked harmful ultraviolet radiation. Before ozone, land was blasted by UV, complex life impossible. With the shield in place, the surface became safer. The stage was set for life to become more complex, and eventually to leave the oceans and venture onto land. For billions of years, life was microscopic. Then, around 541 million years ago, something incredible happened. In a geological blink, animal diversity exploded. The Cambrian explosion. Suddenly, oceans filled with complex multicellular animals. Hard shells, external skeletons, complex body parts appeared. Life's own Big Bang. Why? A rise in oxygen, the end of snowball Earth, and the evolution of predation. Innovation raced ahead. New defenses like shells, spines, new weapons like claws, jaws. Anomalocaris, a large predator with grasping claws and a circular mouth. Hallucigenia, a spiky, worm-like wonder. Trilobites, successful arthropods with segmented bodies and complex eyes. Sites like the Burgess Shale reveal this strange world and its many extinct branches. The Cambrian laid down the basic body plans for almost all animals today: arthropods, mollusks, and the first chordates. A time of wild experimentation, discovering the power of being big, complex, and diverse. The world would never be the same. For hundreds of millions of years, life was confined to the oceans. With the ozone layer in place, continents were ripe for colonization. Around 470 million years ago, descendants of green algae began moving ashore. They were simple, like modern mosses and liverworts. No roots, stems, or leaves, tied to water. On land, support against gravity, absorbing water and nutrients, avoiding drying out. Evolution provided solutions: lignin-reinforced stems to reach sunlight, roots to anchor and absorb, a waxy cuticle to prevent water loss, vascular tissues, xylem and phloem, to transport life's fluids. Plants grew larger and moved inland. By the Carboniferous, around 360 million years ago, Earth was covered in steamy swamps and forests. Not modern forests, dominated by giant ferns, club mosses, and towering horsetails. Photosynthesis pumped vast oxygen into the air, possibly up to 35%. When these giants died, low-oxygen swamps slowed decay. Over millions of years, buried plant layers became coal. Energy from 300-million-year-old forests powering our modern world. These plants reshaped Earth's face and atmosphere, and laid down the reserves that would fuel industry. With land covered in plants, animals followed. Insects, spiders, millipedes, some grew enormous in oxygen-rich air. Amphibians came next, but were tied to water. The amniotic egg, with a protective shell, unlocked life fully on land, giving rise to reptiles. Dinosaurs appeared around 230 million years ago in the Triassic, rising after a mass extinction. For 165 million years, through the Jurassic and the Cretaceous, they dominated. From chicken-sized Compsognathus to colossal Argentinosaurus, long-necked Brachiosaurus, armored Stegosaurus, and the fearsome Tyrannosaurus rex. They lived on a warming world, Pangea forming and breaking apart, humid climates, no polar ice caps. Dinosaurs ruled the land, giant marine reptiles ruled the seas, pterosaurs commanded the skies. Not all were lumbering giants. Many theropods were fast and clever, feathers for insulation, display, and eventually flight. Birds are living dinosaurs, even that pigeon in the park. Spectacularly adapted, they thrived in a lush world built to feed giants. The reign of the dinosaurs, 165 million years, ended suddenly about 66 million years ago when a 10-kilometer asteroid or comet struck near today's Yucatan, creating the Chicxulub crater. More powerful than 1 billion atomic bombs, tsunamis raced, earthquakes struck, volcanoes roared, trillions of tons of dust, soot, and vaporized rock blasted into the sky, shrouding Earth. Sunlight failed, an impact winter gripped the planet. Without light, plants and plankton died. The base of the food chain collapsed. Herbivores starved, then carnivores. The Cretaceous-Paleogene extinction wiped out about 75% of species, non-avian dinosaurs, giant marine reptiles, and pterosaurs. The world fell silent, a sobering reminder of life's fragility. But every end is a new beginning. Small, burrowing mammals, able to eat insects, roots, and decaying matter, survived the darkness. Among the survivors were our ancestors. The death of the dinosaurs was the dawn of the age of mammals. In the aftermath, mammals, once small and shrew-like, seized a world without giant predators. They diversified rapidly, filling empty niches. Some returned to the sea, whales, dolphins, others took to the air, bats. On land, horses, saber-toothed cats, and giants like Indricotherium. Key adaptations: warm-blooded bodies, live birth, milk to nourish young, larger brains, sophisticated behaviors, social structures, problem-solving. Primates evolved for life in trees, grasping hands and feet, forward-facing eyes, depth perception. Around 20 million years ago, climates cooled and dried, forests shrank as grassland spread. A new challenge and opportunity. Some apes spent more time on the ground and evolved a new way to move, walking on 2 legs. Hands were freed to carry food, tools, and infants. The stage was set for the appearance of our own species. The journey from those first bipedal apes to us was not a straight line. A bushy tree of many hominins coexisting and competing. Australopithecus, like the famous Lucy, walked upright with a small brain. Then came our genus, Homo. Homo habilis, the handyman, made stone tools. Later, Homo erectus learned to control fire, for warmth, protection, and cooking, fueling brain growth. Our species, Homo sapiens, appeared in Africa around 300,000 years ago. For a long time we shared Earth with Neanderthals, Denisovans, and others. Perhaps it was language, symbolic thought, art, cooperation, and rapid innovation that set us apart. We survived as others vanished. We spread from Africa to every continent, from the frozen Arctic to the driest deserts. Since the last ice age, we invented agriculture, settled in villages, built towns and cities. Science and industry gave us power to reshape the planet on a global scale. In Earth's long story, our rise was a blink. We are made of stardust, heirs to cells, cyanobacteria, Cambrian creatures, dinosaurs, and the first mammals. We can understand this story, and we bear responsibility. The story of Earth is not over. We are writing the next chapter now. The future of this rare blue marble is in our hands. Let's make it a good one.